those culverts, kind of the concrete tubes that go between ditches on either side of the road. I've heard successful stories about that. So there's regular radar and Doppler radar, and I think I talked about this earlier when we talked about how do we get our information of what's happening in an atmosphere. But Doppler radar can measure the speed and direction of precipitation. Doppler radar can measure the speed and direction of precipitation. Now, I'm going to show you how we can use Doppler radar here in a minute to basically get a sense that we definitely have rotation on the ground that might be a mesocyclone or it might be a downright tornado. So Doppler radars use what we call the Doppler effect. And the Doppler effect works if you have an object that's moving either towards you or away from you. It's what we call radial motion. And what the Doppler effect basically does is if the object is moving towards you, then, and I'll show you a picture here in a minute, but wavelengths between you and that object that's moving towards you will become shorter. If that object is moving away from you, wavelengths between you and that object will get longer. Moving away, wavelengths between you and that object will become longer. So the Doppler effect, and sometimes I'll tell students that the Doppler effect, I know you've heard it before, because picture yourself like this guy, right, standing here. This is you, standing here. And you see an ambulance moving towards you. Now the Doppler effect says that the wavelengths that that ambulance might be emitting are going to shorten. So if we kind of think of the sound think of that ambulance emitting a sound, because you know it's got the siren going. So actually the sound of the siren, the wavelength that it's emitting will get shorter. And we interpret that as a pitch going up. Now, have you ever heard, not necessarily an ambulance, or it could have been an ambulance, coming towards you and it goes, you know, like the sound kind of ramps up, and what you're hearing is the Doppler effect, okay? And then after it goes past you, it goes, it's coming towards you, and then it goes, then you kind of hear the pitch go down as the thing is receding. So here we have the ambulance going away, okay, and then we have a Doppler effect, but the Doppler effect is that the wavelengths are getting longer. And that translates in sound to a pitch getting lower. So if something's coming towards you, the Doppler effect is that the wavelengths get shorter, and in sound-wise, that means your pitch goes up. If something's going away from you, the wavelength will get longer. And if you, in terms of listening, your pitch will go down. So this is kind of another figure from your textbook to kind of show this Doppler effect. So the way this works is we have position 1, and then it's going to move to position 2, position 3, and position 4. And can you kind of see that the wavelengths relative to the person here are going to be squished together, and the wavelengths relative to the person here are going to be lengthened. Okay, so this is the motion of that dot. Okay. Doppler effect. So what meteorologists then can use the Doppler effect for is this. Now, kind of from left to right, you see two images of the same storm system. This is regular Doppler. I'm sorry, I said that wrong. This is regular radar. Okay, and what regular radar does, and we're used to looking at regular radar, is the colors tell us an intensity of the precipitation. Basically, we're just simply looking for an echo off of precipitation to come back. And it's color-coded, so we get the most return of our echo here where it's red. Okay, so that means it's precipitating a lot. Here it's precipitating not so much. The dark green even less, and the light green even less. So we get a sense for not only where the precipitation is happening with regular radar, but kind of its relative intensities. All right, so now this one is Doppler radar. And what this, I just want you to focus on the colors for now. What the color is telling you is the direction that that precipitation is going. So what we're looking for, if you kind of think of at the ground, if we do have a tornado, then it will be rotating, what did I say, counterclockwise. And so basically, if you are here, if you are the observer, you'll see a segment going away and a segment coming towards. And this will give you two different colors. This will give you a red-green, what we call a tornado vortex signature. And I know my red's not showing up, but can you kind of see right in there? And that corresponds to, here in a minute, we're going to call this the hook portion of this regular radar. And here is the tornado vortex signature of the Doppler radar. So the hook echo, and I kind of showed you a minute ago, is what we get from, we can see it in Doppler radar too, but just regular radar can kind of show us the hook. And I'm going to show you some examples here in case you all become meteorologists. But I think a classic example was kind of the one I showed you where it, I don't know if I'm going to kind of butch this up. This is kind of how our precipitation is, and that sweet spot, the hook, is right here. Okay. Now, what's happening there at the hook actually is we have our mesocyclone, because do you remember that we said the mesocyclone will wrap around the updraft and the downdraft, and that's actually what's happening right there. So the tornado vortex signature is, and I might have said vortex tornado signature. Tornado vortex signature is basically then using Doppler radar to see that segment that is coming towards you. Let's see, which color is which? Rapidly rotating, red moving away, green moving towards. Red away, green towards. Okay, so if you're right here, this would be green, and this would be red. I know it's kind of a subtle thing, but if you can kind of get that sort of coupling of colors, and it is in here in the hook, then you have rotation, and you have a tornado, or it might be a mesocyclone, but most likely a tornado. So here is another cell, and it's a little less obvious maybe, but this is the hook part, and it corresponds to this region right there. Another one, can you find the hook? And you know, a hook echo then is looking at regular radar echo, looking kind of at the pattern of precipitation, looking for where that sweet spot is, where that kind of the updraft and the downdraft are wrapping around each other. And then you look for some reflectivity that is coming and going. You look for rotation. By the way, if you're familiar with radars, this actually kind of, these spots right there and right there, those are kind of anomalies. That just kind of goes along with the radar equipment in and of itself. If something gets too close to radar equipment, I'm thinking it doesn't work very good. But this actually was an EF5 tornado. Was that the one in Norman, Oklahoma? Norman, Oklahoma, that is actually the city that puts out our severe weather or our outlooks. So I always kind of find that ironic and sad when they get hit by severe weather. So chasing tornadoes, I don't advise it, but maybe you know, let the professionals do it. If you are a trained weather spotter, they try to kind of give you some safety tips if you are going to chase tornadoes. But notice that that's a mobile radar. Isn't that kind of fun? This is, and what you'd really need to confirm that this is a wall cloud is it to be animated, wouldn't you? So you'd be looking for rotation. If you're looking down at it, it's going to be counterclockwise. So in my estimation, it would be going like that. But it does look like a wall cloud. This gizmo this orb is a picture of a Doppler radar. There's another mobile normal radar. Our National Weather Service locations here in southeast Iowa, in our neck of the woods, we are grateful for those folks in the Quad Cities National Weather Service. And I kind of just end with, this seems like an afterthought to me. Living here in the Midwest, and I've never really been near an ocean, but they can have conditions that create what we call water spouts. And there's some similarities between water spouts and a very, very weak tornado. But there you go.